Hi students, I am Priyanka Jain and I am a verified educator at the Unacademy Plus platform. You can watch several of my Plus classes. Okay, I have soon started a Catalyst batch course for the whole inorganic chemistry. You will see whole the inorganic chemistry in this course, and this is for the upcoming June 2022 exam of the CSIR net as well as for the GATE exam. Okay, so if you want to see different of the my lectures, different courses, you can see on the Unacademy. Take the subscription of the Unacademy. And if you want to see the free classes, there are also several free classes. Every month I take several free classes. You can watch these free classes without taking subscription. So for this, you will have to uncode my code. My code is Priyanka Jain 10. By clicking on this code, you will get the link for my classes. Thank you. Hi students, welcome in chemistry classes. I am Priyanka Jain and you are watching the chemistry of P block elements. Here we are understanding about the halides of sulfur. Sulfur forms a large number of halides. Some of these are fluorides, some are chlorides and some are bromides. Okay, so see here the fluorides are of the type S2F2, SF4, S2F10 or SF6, out of which SF6 is most common. Okay, then it forms the chlorides S2Cl2, SCl2 and SCl4, and it forms one bromide, that is S2Br2. Okay, now you can see that the sulfur is forming SF6. Here the 6 fluorine atoms are attached to one sulfur. Sulfur is present in high oxidation state +6 and it can accommodate the fluoride ions. 6 fluoride ions. Why? Because the fluorides are very small in size and it is highly electronegative. Okay, so the sulfur in high oxidation state can accommodate these small size and highly electronegative fluorides, but it cannot accommodate the chlorides and bromides. So it is not forming the hexachloride or hexabromides, right? So first of all, we will understand about sulfur monoxides. Sulfur forms the monoxides like S2F2, S2Cl2 and S2Br2. Okay, these are the monohalides of sulfur. Firstly, see S2F2. It is prepared by the direct fluorination of sulfur with silver fluoride in a dry apparatus at 125 degrees centigrade. So when we are reacting them, what is happening? We are getting disulfur difluoride and 2Ag. Okay. Similarly, see the preparation of S2Cl2. S2Cl2 can also be prepared by direct chlorination of molten sulfur. If we are taking the molten sulfur and we are chlorinating it directly, it is forming S2Cl2. Okay, and if we are talking about the H2Br2, then it is prepared by direct reaction of the elements. It means direct, the sulfur is reacting with the bromine and it is forming S2Br2. The reaction is happening at 100 degrees centigrade. Okay, so these are the preparation of sulfur monoxide, sulfur monohalides. Okay, now see the its properties. Alright, now see the properties of the sulfur monohalides. S2F2. S2F2 can be rapidly hydrolyzed in water to give sulfur, HF and a mixture of polythionic acids. How the reaction is happening? See here 5S2F2 is when treated with water. Okay, we are hydrolyzing it with water, then we are getting a mixture of sulfur 3 by 4 S8. This is the form of the sulfur and it is forming hydrogen fluoride and it is forming polythionic acid S2SO6. Similarly, for S2Cl2, see the reaction of S2Cl2. The solution of S2Cl2 is when treated in CCl4 carbon tetrafluoride with NH3. S2Cl2 is when treated with NH3 in the presence of CCl4 solution. Okay, at 50 degrees centigrade, what is happening? It can react with this. This is a very important reaction. Several times it is asked in that question paper. So we are getting S4N4, tetrasulfur tetranitride plus 8S plus 12 NH4Cl. Okay. Similarly, one more reaction. See here. This reaction can also occur in the different way. When it is treated with 4NH4Cl, when we are treating it with the NH4Cl, it is forming S4N4 plus 8S plus 16HCl. Okay, in both the reaction we are getting S4N4. So actually this is a preparation reaction for the tetrasulfur tetranitride. Third reaction, see here, 3S4N4 tetrasulfur tetranitride is when reacted with S2Cl2 in the presence of CCl4, and when it is heated, okay, so we are getting 4S4 and 3 plus Cl minus. If you are looking at its structure, actually the structure of the sulfur monohalides, it means S2Cl2 is similar to H2O2. As we have seen the structure of H2O2, or we have seen the structure of O2F2. In both the structures you have seen these are the non-linear structures. Similarly, the structure of H2F2 is like this. Okay, this is similar to H2O2. You have seen the structure of H2O2. This is like this. Okay, so similarly the structure of H2F2 will be this one, and similarly the structure of H2Cl2 will be this one. Okay, so this is a non-linear structure. Alright, now see sulfur dihalides that are of the formula SX2. Actually, the SF2 sulfur difluoride is quite unstable. Okay, so this is not found. Now we have to see about the SCl2. This is the only known halide, only known sulfur dihalide. So see its preparation, 2S plus Cl2 when we are treating molten sulfur. Okay, when we are treating molten sulfur with the chlorine, it is forming S2Cl2, and when it is treated with Cl2 FeCl3, it is forming SCl2. Okay, if we are seeing its properties, first of all, if we are seeing the pure liquid, if we are taking the pure SCl2, then it is unstable. Why? Because there exists an equilibrium. Okay, there exists an equilibrium. 2SCl2 is converted to S2Cl2 plus Cl2. Okay, SCl2 can be stabilized by adding a small fraction of PCl5. If we are adding to the pure liquid a small amount of PCl5, then this solution becomes stable. Okay. Okay, if we are doing the oxidation of SCl2, SCl2 can be oxidized in air and it can form a mixture of SOCl2 and SO2Cl2. Okay, third reaction, if we are reacting SCl2 with F2, then it is forming a mixture of SF4 and SF6. Okay. Fourth reaction, if we are reacting it with the sodium fluoride, 3SCl2 is when treated with NaF sodium fluoride, then it is forming SF4 plus H2Cl2 plus 4NaCl. Okay. Similarly, it can add across the olefinic double bonds. SCl2 is when treated with the olefins, it will react along the double bond and it will form S, CH3, CH2, Cl whole twice. That is called mustard gas. Now look at its structure. Actually, if you are seeing the structure of SCl2, okay, if you are seeing its structure SCl2, if you are finding out its hybridization SCl2, sulfur is the central atom, right? And sulfur is having the 6 valence electrons. So, half 6 plus 2 monovalent atoms are attached to it. It means 8 divided by 2 will be equal to 4. It means 4 hybridized orbitals are formed. So sp3 hybridization is occur here. Okay. Now 4 sp3 hybrid orbitals are formed. out of which 2 will be bonding pair of electrons, because these are accommodating the bond pair of electrons of HCl bond, okay, and 2 will be lone pair of electrons, right? So the structure will be like this. These two positions are occupied by the chlorine atoms and these two positions are occupied by the lone pair of electrons. So what is the structure? The structure is angular. Okay, we can call it angular structure or we can call it V-shaped. Okay. Alright, now see the sulfur tetrahalides. There are two types of sulfur tetrahalides. One is SF4 and another one is SCl4. Okay. So out of which firstly we will study about the SF4. Actually the one important type of the halide is sulfur tetrahalide. How it is prepared? See its preparation. When the molten sulfur is treated with 4COF3 cobalt trifluoride, okay, it is forming SF4 plus 4COF2, right? Now see its properties. First of all, it is thermally stable. It means by the effect of temperature, it will not get dissociate. Okay. And second, it is used as fluorinating agent. Okay. And third one, it can act both as the Lewis acid as well as the Lewis base. It can act both as the Lewis acid as well as the Lewis base. If it is acting as the Lewis acid, if it is acting as the Lewis acid, SF4 is treated with C5H5N. Okay, it is forming C5H5N SF4. Okay, this will have a square pyramidal structure. Okay. Secondly, it can act as the Lewis base. Okay. What will happen when it is acting as the Lewis base? It will react with the acids like BF3. Okay. And it is forming the adducts like this SF4, BF3. Here it is acting as the fluorine donor. Okay. Fluoride donor. It means it is forming the compounds like this SF3 plus BF4 minus. In this manner, okay, it is acting as the fluoride donor, so it is acting as the base. Always understand, whenever any species is accepting the fluoride ion like this is acting as the acid, and whenever any species is donating the fluoride ions, then it is acting as the base. Okay, similarly one more reaction, SF4 plus ASF5, it is forming the adduct SF4 ASF5. Here ASF5 is accepting the fluoride ions. Okay. Similarly SF4 plus SBF5. Okay. Here SF4 is donating the fluoride ion and SBF5 is accepting it. Okay. Third reaction, it can react with I2O5, iodine pentaoxide. When it is reacted with it, what the reaction happens? It is forming 2IF5 plus 5SOF2. Okay. Similarly, it can react with BCl3. 4BCl3. Okay. Is treated with 3SF4 and it is forming 4BF3 plus 3SCl2 plus 3Cl2. Okay. Similarly, it can undergo the oxidative addition to give S plus 6 compounds. SF4 is when treated with F2. It is forming SF6. Okay. Similarly, SF4 is when treated with ClF. It is forming SClF5. Okay. Here the oxidative addition is happening. What is meaning by oxidative addition reaction? If you have studied about the organometallics, then you all know what is the oxidative addition. It means here the oxidation of the sulfur is happening, and beside this there is the increment in the coordination number. It means both the coordination number and the oxidation state are increasing. Okay, so this is the oxidative addition reaction that is happening here. So you can see sulfur is here oxidizing as well as its coordination number is increasing. Okay, next reaction, SF4 is reacting with O2. Again the oxidative addition is happening and it is forming SOF4. Now see its structure. What is the structure of SF4? If you are looking at its structure, see here SF4, if you are finding out its hybridization state, then half sulfur is having 6 electrons plus 4 monovalent atoms are attached to it. Okay, 6 plus 4 10 divided by 2 will be equal to 5. Okay, so 5 hybridized orbitals are needed. So the hybridization will be sp3d. Okay, so the geometry should be trigonal bipyramidal. Okay, so see here, when the geometry is trigonal bipyramidal, put here the sulfur, one point this one, second, third, fourth and 5. These are the 5 positions. Okay. Now in trigonal bipyramidal, 5 hybrid orbitals are available. Okay. Out of which 4 will be bonding pair of electrons and 1 will be a lone pair of electron. Okay. So the lone pair will always take the equatorial position to avoid the repulsion state. Okay, so the 4 fluorine atoms will be present here. Okay, these are the fluorine atoms. Okay, so 2 fluorines are axial, 2 are equatorial. So the shape, if you are seeing the shape, it is seesaw shape. Okay, this is called seesaw shape. Okay, similarly now see the structure of SOF4. SOF4, it will again having the sp3 dehybridization. You can find out it. So it should have the trigonal bipyramidal geometry. Okay, so out of the 5 positions, 4 are occupied by the fluorine atoms and 1 is occupied by the oxygen. Okay, now you know that the fluorine is the highly electronegative. It is more electronegative, and according to the Bent rule, if you have seen the Bent rule, you know that the highly electronegative substance will occupy the axial position. Okay, and less electronegative substance will occupy the equatorial position. Okay, so this will be its geometry, right? Now see one more structure, this SF4 double bond CH2. Okay, this structure. So in this structure, what is happening? See here, you can understand this is also sp3d hybridized. Okay, and there are 5 groups. 4 are the fluorine atoms and 1 is the CH2 group. Okay, so what is happening? This CH2 group is present at this equatorial position. Okay, and 2 fluorines are equatorial and 2 fluorines are axial. Okay, so in this way this geometry is trigonal bipyramidal like this. Okay, now see the next one, that is sulfur hexafluoride. Sulfur hexafluoride means SF6. Okay, SF6, how it is prepared? See here, its preparation, it is prepared by direct reaction of molten sulfur with the fluorine gas and it is forming SF6. Okay, now see its properties. First of all, it is highly stable. It is highly stable. It cannot be hydrolyzed. It cannot be hydrolyzed. Why it cannot be hydrolyzed? Because there are some reasons. First, it is having the high bond length. Sorry, high bond strength. Okay. It is having high bond strength of SF bond. Second thing, the sulfur atom is coordinatively saturated. And third thing is that there is lack of polarity. So due to these 3 reasons, this molecule is highly stable and it cannot be hydrolyzed. However, if we are attacking it with the boiling sulfur, okay, if we are treating SF6 with the boiling sulfur, then it is forming Na2S plus 6 NaF6. Okay, so it get hydrolyzed by boiling sodium. Okay, now see its structure. If you are seeing its hybridization state half, the number of valence electron in sulfur is 6 plus 6. Here are the monovalent atoms. So you are finding out here 6 hybrid orbitals are needed. It means sp3d2 hybridization is present, right? So the shape or the geometry should be here of an octahedral. Okay, geometry should be of octahedral, and now we know that 6 hybrid orbitals are needed and there are 6 bonding pairs of electrons because there are 6 fluorine atoms present. Okay, so its shape will also be of octahedral like this. Okay, so this is its shape, octahedral. Okay, so this is all about the halides of sulfur. Meet you in the next video with some more topics. Okay, and if you are wanting some more topics, you can ask me, you can comment me. Meet you in the next video. Thank you.